Solving quadratic inequalities. Here's an example for you with a coefficient on x squared that is different than 1, the negative 2. So this is actually going to take a more sophisticated version of the factoring method we discussed in class. Also notice on this trinomial we have less than or equal to with 0 on the right-hand side. Remember, we always want this equal to 0 if we intend to factor or to use the quadratic equation. With the less than or equal, we're going to do step 1. And what that is to use an equal sign, then to go back during step 2 and evaluate using either region testing or a graph to determine when this quadratic is less than 0. So again, first I'm going to rewrite this. With an equals. We do this because the inequality does not hold up through some of the processes that we use when factoring. The equals sign, however, is much stronger and it will hold up and remain true. So as we do this, the first thing we want to do is to try to factor this quadratic. The procedure that I mentioned in class is called the grouping method. And to do that, what we do is look for two numbers that multiply and add. So we take the first coefficient here, the negative 2, and multiply that by 20. This gives us negative 40. Then we look at the center term, the coefficient on that, that's a negative 3. And what we are looking for here is two numbers that multiply to give us negative 40 and add to give us negative 3. So negative 8 and 5 work here for making both of these prerequisites happy. See, negative 8 times 5, that will give me a negative 40. Remember, signs are important. And a negative 8 plus 5 will give me a negative 3. Again, this time the problem is slightly more advanced because we do have a coefficient that is not just a 1. So I'm going to show the full grouping method. What we do here is we take the center term and we are actually going to split it into two other terms using the special numbers that we found. So here this negative 3x is actually going to be rewritten negative 8x plus 5x. Please notice that the variable x is also written on these two new terms. Then I'm going to bring down the negative 2x squared, the plus 20, and the equal 0. Now with the grouping method, what we will do is group this 2 by 2. So we will look at the first two terms, then we will look at the second two terms, each time pulling out our greatest common factor. So with the first two terms, please notice that we have a negative 2 that can be pulled out of both of these pieces, and we also have an x. So I'm going to say the greatest common factor is negative 2x. So let's see, negative 2x multiplies by x to give me the original negative 2x squared back. Negative 2x multiplies by a positive 4 to give me that negative 8x that we had originally. So these two right here multiply to give me negative 8x. Now we ignore this first side and move on to the right-hand side. The greatest common factor that we have over here would be just a 5. So I'm going to put 5. Always remember to attach here with a plus or a subtraction symbol because we are pulling out a number and we're attaching it with an addition. This is not multiplication here. So we have 5, positive, and then we say to ourselves 5 times what will give me the first term? That would be an x. 5 times what gives me 20? That would be a positive 4. With the full grouping method, what you are looking for is for the pieces that you have just now grouped in parentheses to match exactly. So here we have x plus 4, which is exactly what we need. Because now we can write that repeating piece one time, the x plus 4, and then we can go back and take the negative 2x plus 5 from the front of this. So I will put the negative 2x plus 5 together in parentheses. And all of this is equal to 0 still. So now what we can do is go ahead, because we have 0 on the right-hand side and two factors, so two pieces attached by multiplication, we are allowed to split this into two pieces, into two different equations. X plus 4 equals 0, and negative 2x plus 5 equals 0. Okay, so solving these for x, please notice subtracting 4 on both sides here will give us x equals negative 4. And then, of course, we'll subtract the 5 to both sides here. Negative 2x is equal to negative 5, divide by negative 2, divide by negative 2. So we have that x is equal to 5/2. This is the end of step 1 for this quadratic. So we basically have our two x-intercepts for this quadratic. We do not yet have the less than or equal to 0 part, however. So I'm going to make a little note about what these solutions were. And then we can graph this together and take a look at where the solution will actually lie, the intervals for where this quadratic is less than or equal to 0. Okay, so again, here we have x equals negative 4, x equals 5/2, our two x-intercepts for the quadratic simply set equal to 0. So now we need to go back and take a look at the less than or equal to 0 part. You may remember here that you have two options. You can either graph this inequality, or you can use region testing with this inequality. I'm going to choose to graph because it's really quick. We basically just use the x-intercepts and the negative in front to kind of give ourselves a rough sketch of this picture. So here we know, because of the negative on our leading coefficient, that this is going to be a quadratic that is pointing down. We also know the quadratic is going to cross the x-axis at negative 4 and at positive 5/2. So we really don't even need to make this to scale. We just need to kind of represent what's going on. So over here we have negative 4, and on the right-hand side we have 5/2. Again, we're looking for when this thing is lower than or equal to 0. And when we are comparing, we're comparing it to the x-axis. So let's see. This part of the picture up here, kind of the semicircle part, this is greater than 0. It's above the x-axis. This part down here, however, right there, this is less than 0. And of course, if we want the equal to part, we will also include the points, negative 4 and 5/2. So the idea is this quadratic is pointing to the left forever. It's also pointing to the right forever, technically. So the solution for this problem will be x coming out of the interval negative infinity until negative 4, inclusive for that negative 4 because we do have an equals on our inequality, union, and then we will say, okay, from 5/2 until positive infinity. Oh, excuse me. This right here will actually also be inclusive because we have an equals on our inequality symbol. So this is the end of step 2 for the problem. So now we have completed finding the solution for this.